Okay, I got this power supply from AliExpress, and it is a 240 volt power supply, and I didn't realize when I bought it. Still sort of works. It makes a buzzing noise, so there's some sort of weird, frequency stuff going on. But it does output 11.7 volts, not quite 12 volts. It's a 12 volt power supply, by the way, for LEDs. But when I hooked up the load, like a little fan to it, it bogged down to I think it was 11.43, something like that. But yeah, it's probably not good to run it on 120 volts. It's struggling. So I'm going to try a mod on it, and I'm no way have a, extensive knowledge of electrical stuff, but I think I know what I'm doing here. I think I finally wrapped my head around this mod. It's a voltage doubler circuit. So I'm going to take the main DC input or output caps. I'm not sure which one they are. The ones that are right next to the bridge rectifier. And I'm going to, right now they're in parallel across the positive and negative, parallel to each other. And I need to make them both in series to each other, and then take the center tap between the two and hook it back up to the one of the AC inputs to the bridge rectifier. Okay, so excuse my awful handwriting, but I realized that it'd be easier if I just showed the circuit and how I modified it. So this is a drawing of the way the circuit was configured originally, and then this is a drawing of how I modified it with the center tap between the two capacitors connecting to one of the AC inputs right here. And that's really all it is. This is what I was saying, that they're parallel to one another, and then I made them in series to one another. So yeah, that's about it. And then my notes of before and after the mod, the voltage, as you can see, doubled because this is a voltage doubler, but the output voltage remained the same, and that's why I'm confused. But yeah, just wanted to make a quick interjection there. That should double the DC output voltage, because right now the DC output voltage is 166, and it should be 330 or so, somewhere around there, for the power supply to work properly. But obviously without the 240 volt input, it's not able to reach that. So this circuit should double the voltage but have the current, which I think makes sense in my mind. Still not quite sure how that all works by what I'm doing here, but I'll trust the process and give it a try. And if it blows up, I will not be mad or anything, because this thing, I returned it basically and got my money back, and they said no need to return it, so you can just keep it. So I thought I might as well see if I can make it work. So here we go. Wish me luck. So I already put some flux on these. These are the two capacitors. This, and this are the two capacitors. This 4 big pads are the bridge rectifier. The DC outputs are on left and right. That's negative and positive. This is the AC inputs. And yeah, these are the two capacitors in their current configuration. So I'm going to take the, the negative leg of this first capacitor and the positive leg of the second capacitor, take them out of this circuit, and then just connect them together on top of the board. So I'm going to add some leaded solder and then suck out. Add leaded solder to lower the melting point, make it easier to suck out the other solder. Let me turn up my iron a little bit. Let's do 375. It's looking better. Make sure it gets all down in the joint. Make it a lot easier. Okay, that's probably good. Grip solder sucker ready. I think that's nearly done it. Might be able to just wiggle it out and try and go over it one more time. Usually doesn't work well without a decent amount of solder suck up, but it did that time. So yeah, that looks clean now. Try it on this one. Yeah, I think I can work with that. Might have to add some heat and wiggle the legs to get them out. Grab some tweezers. And I think this one should just come right out. Yep, and it did. This one might give me some trouble. Oh. Nope, it came right out. So now I'm going to just solder these two legs together. Might grab some pliers and see if I can twist them together a little bit. Some needle nose pliers here. Bend this component out of the way a little bit. This might be a fool's errand. Don't want to rip the legs off these caps, but it'd be nice to have a little bit of mechanical strength along with the solder. Because I'll probably put this into service. And again, I do not recommend anybody opens up, plays with power supplies. There's dangerous high voltage in this. I sort of know what I'm doing, but I'm doing this at my own risk. So yeah, don't copy me. If I do this wrong or whatever, mod fails, it could cause a fire or be electric shock hazard. So yeah, don't try this at home. Those look like nice and twisted up. I'm gonna go ahead and solder them together. Yeah, looks good. Now I need to run a wire from the center tap here to one of the AC inputs. I'm pretty sure it doesn't matter which. Yeah, I think I'll just run it to, should I run it on the top of the board? Just like, maybe I can bend this over a little bit. Yeah, I think I'll just run it down to the one that's closest right there. Let me grab a little bit of decent size wire to keep little scrap bits of wire. I have a bunch of this nice silicone wire, but whenever I have little scrap bits, I save them because it's kind of expensive. Nice copper wire. And just strip this stuff with your fingernails. It's really nice. This is 22 gauge, I believe. Or this might be 16 gauge. Or 18 gauge. This is 18 gauge, so this should be more than enough. There we go. Got this little jig that I 3D printed. It's pretty nice. They sell these on AliExpress, and it's just such an easy thing to 3D print. It works really well for tinning wires. Oh yeah, you know what I like to do with this is put a little bit of blue tack down. That way it doesn't move around. It's kind of too late now, but Well, not really. I'm doing this side. But yeah, that's just a nice little tip for you. Makes it nice and stable. Okay, now I will kind of want to put a bigger blob of solder on there just to make sure it makes a good connection. That's probably good. Add a little bit of flux to this point and this. I'll tin that little part of the pad. Try not to melt everything in the process. And it's kind of blobby, but it looks like it should work. And let's solder this to here. Solder's kind of dripped down, so I'm going to solder it from underneath. And this wire's too long, but I'm too lazy to cut it. It's a bit tricky. There we go. That should do. Let's tuck this down in there maybe. Make it fit in the case again. Yeah, I'd say that's a mod done. And let me just visually inspect it. Yep, looks pretty good. These traces should go through where they need to go to, even though I took those out. Those weren't making the connection. Let me clean it up a little bit and we can test it. It's isopropyl alcohol. Kind of tough to get down in there. This is by no means necessary, but just might as well do a clean job while you're at it. And yeah, that's it. I'll let that dry off and then we can test it. Bend these back into position. All right, let's test this out. Hope I don't get any smoke or explosion. So, plugging it in, the power strip is off. All right, I got my safety squints on. I'm turning my head, and I'm gonna hit the power button now. Hey, the light's on. It's still making a buzzing sound, but it's a different buzzing sound. Okay. Huh. Well, let's test the output from that bridge rectifier. Like I said, last time it was like 166 volts. It should be around 300 something. So, got my multimeter here. And volts DC. See if you can see that. Yeah, you can see that. I'm gonna go just right across the bridge rectifier on the outside, which is the DC output. there you go, 333 volts, just as it should be. Now, before the output, you know, the 12 volt DC output was, what was it, 11.7 volts. And it should have been, oh no, I'm dropping shit. It should have been obviously 12 volts, or maybe a bit above. And it also bogged down under load. And I'm sure it wouldn't have been able to output its rated current, which was 12.5 amps. So yeah, I'm hoping that this is like a solid 12 volts now, because this thing doesn't actually have any like trim pot to adjust the voltage. So let's test it, hope for the best. Oh, it's the same, it's 11.7. Well, that was sort of a fail. It wasn't a catastrophic fail. I thought it was gonna go one of two ways. Either it works perfectly or it completely explodes. But I wasn't expecting this. I don't know if anyone out there knows why it didn't work. Let me know. Like I said, I'm not an electrical engineer. I have no idea what I'm doing. I just came across this on EEV blog and a couple YouTube videos, and that this would be a way to convert a circuit from 240 volt to 120 volt input. So yeah, if you know, leave a comment, but I think that's it. I will maybe not put this into service until I know more about this circuit and how it's acting after the mod.